Hi folks, this is question 9. So we're given a diagram, so it shows the actual daily number of new cases of a disease. So from day 0 to day 25. Uh, so from the diagram, estimate the number of actual cases there were day 12. So on when t is 12, using the relevant dot. So dot is in bold there. So if we go to 12, 12 is about here, and you see that the dot is up above the curve. So this is the dot, so you have to read across there, and you can use a ruler to kind of cover it, but it's approximately exactly halfway between 1,000 and 2,000, so we'll say 1,500. Work out the percentage error in the model's value for the day. Yeah, so it's above the curve. So the curve on at day 12 is about 1,000. So if you look right in there, at where that's where day 12 is, so it's at 1,000 new cases. So I had 1,500 there. Yeah, so it's 1,500, but it should really be 1,000. So from 1,000 to 1,500, there's a difference of 500 there. So we put 500 over the original and multiply by 100, so you can see it's going to be 50%. So it goes up by a half anyway, you can see that. Show that it takes approximately 5 days for the daily number of new cases to double. So it takes approximately 5 days. So you have to just come up with some examples here. So on day 0, day 0, day 5, day 10, day 15, day 20, and so on. So on day 0, it's about, let's say maybe 200. On day 5, it probably is about 400. I'm not just putting that in because it's double. It does look about that on the graph. It looks just a little bit below halfway between 0 and 1,000. On day 10, it's just below the 1,000, so let's say 900. Then on day 15, it's say about 1,500. On day 20, it's a little bit above 3,000. We'll go 3,100. Would that be about right? Yeah, that'd be about right. And then on day 25, it's up above the 6,000, so 6,200 approximately. So you can see there that it is doubling, but there's a small exception, the one in the middle where it goes from 900 to 1,500, so that's not double, but it's not that far away from being doubled. So times by 2, yeah, they're all being times by 2 pretty much. So you've shown that. Hence, estimate on what day the number of new cases will be at least 100,000. Will be at least 100,000. So on day 25, it's 6,200. So then, if it keeps doubling, then for every 5 days, then on day 30, it'll be 12,400. On day 35, it'll be 24,800. On day 40, it'll be 40, 50, uh, could be 49,600. And on day 45 it'll be 99,200. Now they want I'm reading the wrong question. So on an estimate on what day the value of t, the number of new cases will first be at least 100,000 according to the model. Well, it's not 100,000 yet, so on day 45 it's only 99,200. So we assume that on day 46, even though it's not, we're not doubling yet, I mean on day 50 it'll be nearly 200,000. So there's no point putting down day 50 because it's way up above 100,000. So we'll just say day 46, because then it should be, if on day 50 it'll be nearly 200,000, which it will be, then every day along there, day 46, day 47, day 48, it's around 20,000 it's going to go by. So we'll just say day 46. And there has to be a bit of room for error there as well, because it's all estimating, it's hence estimate and so on. So as long as you're showing the workings, you should get all the pretty much all the marks. Right, this one then, first thing, all you have to do is to fill out the table is just put the value in. So you're just subbing in. So you're subbing a 0 in instead of t, and then a 1 in instead of t, and so on. But remember, the power is the t, so you have to be able to find that button on the calculator. So if you sub them in, you should get 2100, 2478, 3450, 4071, and 4804. Right, so if you draw this on the graph, then so 0 and 2100, there, 12478, it's just slightly below 2500, and 2 and 2924, 3 and 3450, 4 and 4071, 5 and 4804, be up here, and 6 and 5669. Yeah, I did the last one wrong, didn't I? 5 and 4808. Be about here. And then 5669 to be up here. So you can see the curve is kind of curving up, something like that. So measures are put in place to slow down the spread of the disease. From t equals 14 days onwards, the number of new daily cases starts to decrease. So for t is greater than or equal to 14, the daily number of new cases on day t can be modeled by this. So on t is 14, there are 21309, so therefore you can sub that in, so you know 21309 is the answer basically to that. So of a multiplied by 0.83 times to the power of t, which is 14, so 14 days. So all we have to do here is you're just going to bring over all of that, so 0.83 to the power of 14. So if you bring it over and divide it, because it's been multiplied on the right hand side, that'll find out what a is. So you should get, calculator will do it for you. You should get 289380.84. But then they want you to put it in this form. It's the into standard form. So you'll need to move the decimal point over. So it'll be 2.89388084. Oh, it's correct to 2 decimal places as well. So we need to round it off to 2 decimal places as well. So 2.90. No, sorry, 89. Just 2.89 multiplied by 10 to the power of, and we see how many places we moved the decimal point initially. So it was 1, 2, 3, 4, 5. So to the power of 5. And you'll need to do that last bit just for all of the marks. So that's it. That's all for that question.